me do a few examples using the standard normal table, some basic examples by hand using the table and using the calculator. What is important to remember to do for any problem when you're trying to find a probability or an area is you want to sketch the distribution and shade the area in question. Okay, so I want to do a few of these in here. Let's take a look at this one here, number 24. I want to find the indicated area under the normal curve to the left of z is equal to negative 3.16. Now, because the letter z is used, I know this is standard normal, where the mean is 0 and the standard deviation is 1. Okay, so what I'm going to do first, okay, is I want to sketch what's being asked. Okay, so what's being asked for this problem is I want to find the probability that z is less than negative 3.16. One thing to keep in mind is that anytime you're asking for an area, that is the identical question as a probability problem. So area corresponds to probability, which corresponds to percentage of area under the curve. Okay, so the probability z is less than negative 3.16 is also the same thing as finding the amount of area under the curve, the standard normal curve, to the left of negative 3.16. So I'm going to go ahead and sketch a bell curve and put the mean of 0 because the standard normal curve has a mean of 0 and standard deviation of 1. Okay, so what this tells me is I want to know how much area is less than 3.16 standard deviations below the mean. Okay, that's essentially what this is asking. So I know since this is negative, I want to be down here in this lower half. Okay, so I'm going to be shading this little bitty tail and putting in 3.16. Okay, so this is the area in question. Okay, so there's two ways I can do this. I can do this using the standard normal table, or I can use my calculator. Now the standard normal table reads cumulatively from negative infinity up to the point in question. So we can actually use the table directly here. So going to my standard normal table, looking at the first page, which has the z-scores that are below the mean, I'm going to scroll down till I find 3.1, negative 3.1, and then move over till I get 0.06. Okay, so the values in the body of the table are the probabilities, and these numbers in the first column and across the first row are the z-scores. Okay, so this area is very small, and that's consistent with what I've drawn. So that area is about 0.0008. Okay, really small. So I probably didn't draw this proportionately correct, but that's fine. Okay, as long as I know I'm out in this little tail below the mean. Now on the calculator, I can also get that corresponding area. This is a cumulative area from negative infinity up to the point in question. So the calculator has a built-in normal CDF, just like it had a built-in binomial CDF. Okay, so I want to go to my distribution menu, which is above the vars key. And you'll see that the second option is normal CDF. Okay, that's the function you always want to use in this course. Now if you have an older TI, it's going to open up on your home screen and it's going to say normal CDF, and it's going to open up some parentheses. Here's the order of the values you need to be putting in. So the first thing you want to put in is a excuse me, really super duper small number. Okay, so really small number. Okay, technically it's negative infinity, okay, because we're going from negative infinity up to the point. Now we don't have a negative infinity button on our calculator, so we're going to be using a really, really small number. Okay, the book has you putting in something like negative 10 with a bunch of zeros, okay? And that'll work. Okay, and then we can go ahead and close the parentheses, all right? Now I know I said, well, there's some more stuff coming. That's in the next section when we cover non-standard normal, okay? But if we went ahead and closed the parentheses right here, closing it tells the calculator we're going to default to standard normal. Okay, and we are finding the probability corresponding to a z-score, so we are working with standard normal. So if you, I forgot a step in there. Sorry about that, guys. Okay. It's been a long day. There is something we need to put here. We're not going to close the parentheses yet. We need to put an upper bound. Okay, so really small number is our lower bound. We want an upper bound next. Crazy lady. And then this is what I was saying. There's more stuff after that corresponds to the non-standard normal case. Okay, but at this point we would then close the parentheses. Okay, so lower bound, a really small number. In this case it's negative infinity. My upper bound in this problem is negative 3.16, and close the parentheses. Okay, so if you have the older calculator, that's what you need to do. On the newer calculator, when you first turn it on, it defaults to a really small number. Okay, so this negative 1 e to the 99 is the calculator's version of something close to negative infinity. So you can just leave that there. If for some reason it's not there, you can put in a really small number, like negative 1,000,000. Okay? And then my upper bound is negative 3.16, and it defaults to standard normal. If I had a mean or standard deviation that was different, then I would just change that. Okay, so I want to scroll down. Okay, so it's indicating an area of 0. Okay, that's a really, really small number. It's not exactly equal to 0. Okay, so remember when we found this using the table, we got an extremely small number. Okay, so keep in mind that's not exactly equal to 0. It usually gives me something a little bit, oops, sorry. This the calculator's thinking I'm further out. Here's my mistake. Okay, it's negative 3.16. Ah. Oh, goodness. There we go. Okay, still pretty darn close to 0. Okay, so this probability or area is about 7.9 times 10 to the negative 4th. Okay, so let's write that out. This is approximately equal to 7.9 times 10 to the negative 4th. Okay, so in other words, in non-scientific notation, I would have 3 zeros and a 7.9, which rounds to 0.008, which is what we got when we used the table. Okay, so the calculator carries it out a little bit further. Okay, now one thing to keep in mind is because this particular z-score is below the mean, I expect this area to be less than a half. Okay, if, for example, the z-score was above the mean, okay, then I would expect my area or probability to be greater than a half because the area from negative infinity up to the mean is 0.5 or 50%. So this is one reason why sketching the distribution is helpful. It should reflect what you expect to get with your answer. Okay, I'm expecting a very small probability, certainly less than 1/2. Okay, so let's take a look at another one. Let's take a look at this one. Let's take a look at finding the area between negative 2.33 and positive 2.33. So again, I want to sketch what's being asked. In terms of probability notation, this is the same thing as saying I want to find the probability z falls between 2.33 and positive 2.33. Okay? We're between those two values. So I'm going to go ahead and sketch a standard normal curve, put 0 in the middle, and shade in between. Okay? So this is the area I'm looking for. Okay, if I wanted to use the standard normal table, one way to do this is to work it in two pieces. Because the standard normal table reads from negative infinity up to the point in question, what I can do is find this total area going from negative infinity up to 2.33 and then subtract out this tail. Okay, that's the part I don't want. So using the table, I can take it apart and rewrite it as the probability z is less than 2.33, subtracting the probability z is less than negative 2.33. Okay, so in other words, I'm finding the total area from negative infinity up to this upper z-score and then subtracting out that tail because I don't want that. Okay, so going to my standard normal table, to find the probability z is less than 2.33, I can first go to this page where the z-score is above 0. So 2.33 is down here. Okay, if I'm reading that right. I know this table is really kind of yucky. Okay, so what do we have? 0.9901. Okay, so that's going to be 0.9901. That's this whole thing, and I want to subtract out this tail that I don't want. So I want to go back to the first page and look for negative 2.33. Okay, so it's a little tricky. So negative 2.33 right here. Okay, so 0.0099. Okay, subtracting 0.0099. Okay, so let me get that value, 0.9901 minus 0.0099. Okay, so we get an area of 0.9802. Okay, this is using the standard normal table in the book. But I can also use my calculator, the normal distribution option. Okay, so if you have the older calculator, you want to open up your distribution menu and find normal CDF. Now my lower bound is not negative infinity. Okay, so this is what's nice about the calculators. We can indicate a lower bound and an upper bound for this in between. Okay, we don't have to use the calculator twice. Okay, so I have negative 2.33 for my lower bound and positive 2.33 for my upper bound, and then close the parentheses, and that tells the calculator you are on standard normal. Okay, on the newer calculator, I'm going to go to my distribution menu and choose to normal CDF, change my lower bound to negative 2.33, my upper bound to positive 2.33. And again, I can leave my mu and sigma alone. Paste. Okay, so I have 0.980, and then if I round to the fourth decimal place, I get the same thing that I got using the table, but this is carried out a bit further. Okay, so I get about the same thing. Okay, so 0.9802. Okay, last but not least, let's take a look at another one. Let's take a look at number 36 here. This is a good one to take a look at. I want to find the area to the left of z is equal to negative 1.96 and to the right of z is equal to positive 1.96. Again, I want to sketch the standard normal curve and shade the area that I'm looking for. So in probability notation, okay, so this is going to be the probability z is less than negative 1.96, or probability z is greater than 1.96. Okay, so we have an or case here. Okay, z is not in between those two values. Okay, I have two separate mutually exclusive areas. Okay, so again, drawing a bell curve and putting 0 in the middle. I've got z is less than negative 1.96, or z is greater than positive 1.96. Okay, so thinking back to chapter 3, I've got a mutually exclusive case. I've got two probabilities and I'm using the or word, so I want to be adding these. So I'm going to be adding this area to this area. Okay? So one way to approach this is to recognize the fact that I have symmetry here. So this shaded area is going to be the same as this shaded area. So really, this is going to be 2 times the probability z is less than negative 1.96. That way I only have to go to the table once. Now if this upper z score was a different value, I'd have to go ahead and find that separately, okay? Because then it wouldn't be symmetric. Okay, so I hope that you recognize the fact that even though I didn't draw this bell curve exactly symmetric, these two shaded areas would be equivalent. Okay, so I can go ahead and get that in the calculator in one step. I can go 2 times the probability. Okay, so normal CDF. My lower bound is a really small number. My upper bound is negative 1.96. And then I can leave mu and sigma alone. Okay, so 2 times that is about 0.049956 and so on. Okay, so this is approximately 0.05. Now I'm sure there's more than one way to do this problem. You could have found the area in between and then subtracted from 1. Okay, that would be an alternative way to do this. Okay, but one thing you would want to remember if you did that method is that if you found the area in between, you would have to remember to subtract from 1. Okay, so I hope that gets you started with Chapter 5. Chapter 5 is used for the rest of the semester. You're going to have lots of practice with the normal distribution.